Um, here we want to create a model, and it's going to be called institutional mobility, or institutional mobility, NC. Okay. And what I'd like you actually to do is I'd like to add in a bunch of different types of agents. This is different than what we've had now. So I'd like to add in agents of different types, each of which is going to have a different depiction, a different icon. So I'd like to add in, as the first type of agent, some homes. So a home type, HOME, okay? Okay, wonderful. Okay, another one, I'd like you to add in workplace. Okay. Another, I'd like you to add in school. Okay. And yet another, I'd like you to add in person. Okay? Person is just one of many types of agents here. Okay. And now for each of these, ladies and gentlemen, we're going to go lend them appearance. So double click on home, and we want to add an icon for home. To do that, I'd like you to go down to this area here, the pictures palette, and I'd like you to add in a house for the home. Okay? We could drag in the house. Were people able to find that? It's down here, way down here. You can go up and down, but it's this one with the sort of person standing next to it, the pictures. I'd like to add a home, to a house to a home. For person, I'd like you to add the little person icon. Okay? For school, I'd like you, we don't really have a great school depiction, but maybe we'll add in the warehouse here. I mean, it looks a little bit like a big school or something. Okay? It's a bigger building. So, again, for school, I'm dragging in from this warehouse. Okay? This is, again, from this palette down here. Okay? And finally, for a workplace, I'd like you to add in from the factory. So I'll go rehearse each of these. I'll go review each of these. For a home, I've added in, these are all being added from this pictures area of the palette. For a home, I added a house. For a person, I added a representation, it says, of a person. For a school, I added a depiction. It said warehouse, but it looked to me a little bit like a school. And then for a workplace, I added a factory. Okay? People okay with that? Okay. Next, I'd like you to create populations of these. Where do these populations live? In Maine. So double click on Maine, and let's drag in populations of homes, and these we'll call them homes. And I'd like you to create a population of size 50 for homes. Okay? I think you know how to do this pretty well. Size 50, right? People comfortable with that? Okay, I'd like you to add in now schools. Schools, and this would be a population of agents that are of size 5. Okay? Next, I'd like you to add in workplaces. And these workplaces will be a population of agents of size 25. Okay? And finally, persons. And I'd like you to call that population. And population is going to be of size 250. Population of agents, 250. Okay? Okay, next, folks, I want to lay all of these out in a random fashion. We're not going to be adding any new ones to the model, so you can use the tried and true traditional technique. Wow, that was 4 T's in a row. Okay, so... Right. So how are we going to add these arranged in a tried and true traditional technique? How do we add these to the population so they're randomly arranged? Okay. Main, scroll down to this area, environment for agents, layout type random. Okay, ladies and gentlemen, I'm going to review the numbers here. For homes, I had 50 homes. For schools, I had 5 schools. Workplaces, I have 25 workplaces. Population, the population of people, I have 250 people. Okay? Can we run it? Let's go run it. Build and run. Okay? And we should see something like that, roughly. Do you see that? Yeah, so we're gonna be picking workplaces and homes and so on. Okay, great. Now, the focus of this model is going to be on the people, and each person will be associated with a home, and depending on their age, either a school or a workplace. Okay, so let's go to person. Okay, so let's go to person, and a person will be associated with a parameter. A person will be associated with a parameter called age in years. Okay? And that's going to be a double. Now, I think, I can't remember if I told you initially, but for this model, I'd like you to make the, I guess I didn't. The time unit should be hours. Where do we go to set the time unit? Anyone remind me? Yeah, to the whole model, right? Yeah. Set the model time units to be hours, but we're going to be having age in years for the person. Okay? Is that okay? Okay. So we've added to person an age in years parameter. Okay. Now we're also going to add to person. Okay. Well, let's before we do that, let's go now back to the population. Okay, let's go back to population, and where would the age in years be set? Where would the assumptions about age in years be set? Can anyone tell me? Yeah, it's in the population in which they're embedded. Okay, oop, hey, come on. Okay, it's in their population. Okay, age in years, we're going to draw this uniformly from 0 to 65, okay?
I'm sorry, could you repeat one more time where you are?
Sure. So we added each of these in, these homes. We associated. So we added to the model, to recap, we added to the model a set of agents. For each type of agent, we lented a visual depiction. And then we went to main, and we created populations of these agents. Homes, there are 50 homes. There are schools, 5 schools, workplaces 25, population 250. Then we went to person, then we went to main and we did the random layout. So in main, we went down and we said to lay it out with layout type random. And then we went to person, and we just added an age and years parameter. That's a double. Sure. Okay? Any other people want me to answer questions about this? Okay. We're humming along, folks. I'd now like you to add in variables here. For yes.
Why do you choose variables for certain? What's the difference between a variable and a parameter?
Okay, great question. What's the difference between a variable and parameter? Both store information. Parameters are distinguished by two basic features in my mind. Okay, basic feature one. While a variable is often used to capture things that are changing over time, a parameter is typically more or less constant. It's not changing over time. Okay, not frequently. It can change, but generally they're fairly static. Okay, so that's one issue. Perhaps the more fundamental issue is that a parameter, in contrast to a variable, a parameter serves as a means of communicating information about the assumptions from the point where it's created to the object in which it's embedded. Okay, so a parameter, for example, for the population size for Maine, that communicates from the experiment to Maine how big its population should be. A parameter that's in a person communicates from the population what assumptions should be in place for that person. Similarly, or when you create a new person, you have to specify those assumptions. So a parameter is used for communication, to sort of communicate the assumptions to be had when the agent is first created, particularly. Sometimes there's information that can't be readily determined when that agent is first created. Maybe it's information that came about later in the person's life. Maybe it's information that requires all the rest of the model to be set up before it can be determined. And for that, we might use a variable to determine it. Okay? And that is the case here. Is that helpful? And we'll see where that's the case. Okay? Okay. Ladies and gentlemen, a great question. Other questions? I would also note that variables and parameters are also initialized at somewhat different times. Variables before parameters, which is another matter. But they're first set up at different times. Okay, ladies and gentlemen, associated with each person is going to be a home. What sort of type is this going to be? It's going to be a reference to a home. People got that? Okay. So we added a variable home that is a reference to a home. Okay? So its type is home. To a person. That's for a person. So a person's going to have a home. I added a variable to that person called home with a lowercase h, and its type is home with a capital H. You know? It's one of the types we can choose. Is that okay? People okay with that? Okay. We're next going to add to a person an associated school. Oh, sorry. Oh, man. Oh, what a horrible thing. Don't let me, oh, what a terrible thing. I'm sorry. Yeah, it'll be a variable. And it will be a school. Okay? And what type is it going to be? It's going to be a school. Yeah, the variable is going to be lowercase because it's representing a particular school. Capital S will be the set of all schools, schoolness. And that's with a capital S, So its type is going to be capital S. Home, school, and then workplace. Okay. Oh, what am I doing? Sorry. Heavy lunch. Okay, workplace. Workplace, and this will be of type workplace, okay? Great. So each person will be associated with a home, a school, and a workplace, but really based on their age, we're going to only use one or the other of the latter two, okay? Okay, I got to be extra alert here. Great. This is the toughest time of the afternoon. while we're digesting. Okay, so we now have home, school, and workplace associated with the person. That's great. So what I'd like to do now is to create a little transition. So we're going to create a state chart. And this will be a state chart entry point. Boom. And this is going to be mobility state chart. Okay. And we're going to, the entry state is going to be home. Okay. It's going to be HOME. Is that okay? Yeah? Okay. Okay. So the first thing we're going to do is for this entry point here, we're going to do something when we enter. We're going to determine what their home is. Okay? We're going to pick a home for them. Can we do that? Okay? We're going to set home. How do we make home hold a certain value, hold a reference to a particular thing? We do a what to it? We assign it. Put an equal sign there. Home equals, and we want to find a random one among the homes in Maine. So how do we refer to all the homes in Maine, the population of homes in Maine? Maine dot homes. And you'll notice that actually there's a thing called, you could just put a dot random at the end of that. Oh, pick a random one. Okay? Is that okay? Main.homes. You have to do space, and you'll see there's only homes. And then dot random, and that's a function call. It's saying, pick me a random home. Yeah, you'll want to go up and probably check in Maine, because it probably won't bite you later, but you should see this up in Maine. It should be homes, population, schools, and workplaces. Probably you should call it, for clarity, you should probably call it homes. Because it's a collection of different homes.
Okay, thank you. And then what?
Yeah. Yep, that's good. And that will head off some problems. Okay? So folks, these are the things in Maine. It should be homes, schools, workplaces, and a population. Is that okay? People okay with that? Okay. So let's go back to person. We're going to be setting their home. Main.homes.random, just like this.
Thank you.
Sure. Is that okay? Yeah. Shakiba. No. No. Time units should be hours. And you're saying, should we specify the age in years?
Age in years, it doesn't need to specify this.
No, as long as we're clear that it's in years and how it's used, we're not going to actually be combining it with the model's time units. And so if we did, we'd have to convert between them. And we can do that in a structured, principled way. But in this case, we don't even have to do that. So you can maintain, in the model, you could say mean time in months and, age in weeks or whatever, as long as you use the appropriate conversions between them. And in this case, we're going to just do a very simple thing with it. We don't even need to combine it with the model's time because we're not going to be having people age or anything. It's a good question, though. Yeah. Yeah. Okay. So, and then, folks, the other thing I'd like to happen is when they come into home, we want them to move to their home. How do we do that? Can you tell me? How would we have this person move towards their home? Head off for home. Okay, this dot move to. This will be in the entry action to the home state. This dot move to what? I wish we could just say home, but we can't. We actually need to find out where home, what its X location is. How do we find out where the X location of something is? We've seen it already. This dot get, home dot get X, and then home dot get Y. Okay? Let me put that up on the big screen here. Okay? Okay?
This comma means to?
No, this dot. Yep.
This dot means to.
Home dot get X and home dot get Y. Yep. Yep, sure. Okay. So folks, let's run this right now. We're going to be refining this. We're going to be extending it, but let's run it right now. Okay? So let's you should run this. And where are people going? They're going home. Okay? In sort of a stately pace. They're going home, just like the song says. Okay? Okay, so that's encouraging. We have people going home. But now I'd like to elaborate this, okay? First of all, let's have them move at a somewhat faster pace. After all, how many hours transpired before they got home there? And after all, this is not a snowstorm in Raleigh. So look at that. It's like oh man, getting close to 30, 45, 50, 60 hours. That's a grim situation. Okay, this ain't no snowstorm. So let's set it so they have a faster velocity. We could set their velocity, and this will be at the entry point. We're going to set their velocity, this dot set velocity, to be 200. In other words, across 200 units of distance within an hour. Okay? 200. That's what that will mean, 200 units of distance, which would be quite a long distance within an hour. Okay? People okay with that? Oh, sure. This is the full text when you're coming into that state. The other part we already typed. But, hey, come on. What are you doing? Copy, paste. There we go. So this is just the assignment to Holmes, and then I set velocity, capital V, as in Victor. Okay? That's occurring here in the entry action to this state. That's actually not occurring here. Yeah. Okay, can we run it? Are people comfortable with that? Okay, let's run it. Okay, boom. They sorted themselves out. In about 2 hours, they got home. Okay. Great. Fair enough. You can play around with the times if you want. Maybe we'll speed that up a little bit more. Maybe make it 400 velocity. They'll tend to get home in up to an hour, so we can run that again. This is not assuming any inclement weather. Okay, fine. So we have people going home. That's great. But let's actually go and now have them circulate among their different other places. So to circulate to their school or to circulate to their workplace, we're going to have to figure out where those are. So this is what I'd like you to do. And again, I'm trying to weave in different features of how you do this sort of modeling here. So first we're going to find, suppose for their school, they're going to be associated with their nearest school. Okay? Okay? So to find out what their nearest school is, there's a method that says get nearest agent. We have to provide it the list of all of the agents we want to consider. So we could say this dot get nearest agent, but we have to give it a list of agents, a set of agents, a collection of agents to consider. What are the agents we want to consider when picking out a school? We want to pick out the schools, yeah. Okay, so main dot schools. Okay, and we don't want to just call that thing, it returns a value, so we want to do something with it. We want to make that our school, okay? But there's a fly in the ointment because we're not at home yet. We actually want to get to our home. We want to teleport home so that it's picked to our home, not to our existing location, okay? So we can actually, how do we set it so that someone goes home really quickly? They teleport. We do jump to. So right after setting their home, let's actually do this dot jump to, and we're going to jump to our home. So tell me how to do that. What do I type? This dot jump to, and then what? Home dot get X, home dot get Y. I jump to that position, okay? And then, now that I'm at that position, I can get the nearest agent to myself, considering among all schools, and make that my school. And I can further get a workplace, okay? Let's make a workplace. You could argue about this, but maybe we'll make a workplace be, for now, randomly chosen. How would I make a workplace randomly chosen? Sorry? Okay, main dot workplaces dot random. That's right. Good. So this is quite a little bit of a handful here, and it merits building early, building often, but I'm going to put it up on the big screen. There we go. Okay, so first we get our home, and then we jump to it. Then we get our school, and we pick our school as the nearest one of the set of all schools. And we pick our workplace randomly amongst the workplaces in this area. And we set our velocity to 400 just so that we won't be pokey and moving around subsequently. Is that okay? Okay. So I'm going to copy this in here and just for formatting. Okay. So now we have things set up, but we want to actually have transitions between two places. One will be our school, and another will be our workplace. Okay, workplace. Okay, now we need to transition between them. What do we need to add to this state chart? A transition. Okay, we're going to add a transition, and we're going to add a branch. I think I heard a branch there. So we're going to add a branch to this transition. And one side of the branch is going to go which way? School, and another side will go to workplace. Okay. Okay. And then we want transitions going in place from the school. Well, let's leave those out for now, just so we could focus on these ones. Okay. From home, let's suppose we say we spend, we're going to make a timeout, and we'll spend 16 hours at home. Okay, that will be, yes, this timeout going from home. And then...
and sorry, to make it
Oh yeah, we said earlier that time unit is hours. We had set it to hours for the whole model, and for this reason. Okay, 16 hours. Okay, for a person, make their transition out here. For this transition, I'm going to say leaving home. It's going to be time out of 16 hours. Okay, leaving home. Okay. Now, for this branch, we're going to have to set one of these to have a certain condition. I'd like to set it, if you're going to school one will have a condition, and that will be if your age in years is less than 18, less than or equal to 18. Okay? It'll be a condition. So it'd be a condition associated with this, okay? And this is the condition associated with going this way. This is the default. Okay? And then we're going to need transitions back from those institutions, the workplace to home, and from the school to home. Okay? There we go. And those two will be timeouts, and they'll occur after 8 hours. Okay? So return home from workplace, and I'll show that name, and return home from school, return home from school, and that will be also associated with a timeout with 8 hours. Is that okay? Sure. Sure. Okay. Yep. So we might do something like this. I like that idea a great deal, actually. So how would we do that? We'd say if age in years less than equal to 18 and age in years greater than 5 or something like that. Now, traditionally, we would have put these in the opposite order to be sort of in rising order, so we sort of delineate the range from 5 to 18. This is how we would tend to write it, but that'll be a fine way too out there. You notice this double equals. That means and. It means this must be true and this must be true. In other words, this person needs to be between 5 and 18 years of age. Yes. No, we're gonna have to put a guard on their transitions. So what my plan is, and actually it would mean that we wouldn't need to specify this age in years greater than 5. Instead, we'd make a guard for leaving home that they are age in years greater than 5, right? Yeah. In which case, we don't even need this condition here going to school in the sense that it's already been enforced by this. They shouldn't have made it down there. It wouldn't hurt. And actually, the better thing to do would be to just verify that it is true, so that if it's not, you flag the error as soon as possible. But yeah, sure.
And the way we write this guard is that the age in years has to be greater than or equal to 5. Guard. Do we want to guard against who we don't want to get out?
The guard will be it's only allowed if this happens.
So greater than or equal to 5.
Yeah, I said greater than 5, but it's continuous, so it's really immaterial. Okay. Okay. So what now? Okay. So we basically hitched it up. So these return transitions have timeouts associated with 8. Okay. And now let's consider now the what we have to do. What's the logic associated with the transition? So if you're going to the workplace, what do you think you need to do? Okay, yeah. So workplace dot move to, oh, sorry. What am I doing? This dot move to what? Okay, it associated with the entry action to the workplace. Or you could do it associated with this transition. It's just if you had multiple transitions added in the future, you might say, well, for all of them, we're going to go to the workplace. So in this case, it's a little bit arguable. So we're going to move to the workplace's X and Y location, right? So I'm just going to copy this code and put this here. This is what we're doing. Oops. Yeah. This is what I did. So I'm moving myself to the, one should say get X, one should say get Y, right? I'm moving to the X, my X location will be the get X at the workplace, my Y location will be the get Y at the workplace. That's the way I'm moving. Okay? And then, how about for the school? What do we need to do there? Yeah, it's basically the same basic pattern, but instead of workplace, it's school.getX, school.getY. So it's this, right? People okay with that? Who needs TA help? Sector 2. TA is deployed. Sure. Okay. So folks, why don't we do an overall recap? I like that idea a lot. So what we've done here in building this up, we've done a bunch of logic up front where we actually determine our home, our school, our workplace. We jump to our home, and then we set our velocity. Okay? That's up front. When we get to our home, or we get to the home state, we start moving to the home state. Okay? Now, we leave home after 16 hours with a guard that we have to be greater than 5 years old. We will go to school if we're greater than 5 and less than or equal to 18 years old. And when we go to school, when we go into the school state, we'll move to the school. The default transition is to go to the workplace. Entering the workplace state, we'll start moving towards the workplace. We return from the school after 8 hours, in the workplace after 8 hours. Are people okay with that? Okay, let's build. Okay, who has a question? Sure. It's in the entry action. We have this. We have here. Let me clean this up a little bit. We have this. But again, the spacing. Oh gosh. Oh my gosh. Yes. Thank you. The perils of copy paste. Okay, and this is get Y, and this is get X, get Y, and this is get X, get Y. Okay?
And then one more thing. Can you click on the home? Look at the entry action that you have for home.
Entry action is to go to the home's X and Y location. Yeah. And I can, Kristen, I'll put it up here. Sure.
Yeah. So okay. This got moved to home. Okay. Good.
Okay? Okay, should we run this thing? You want to run it? I have a feeling maybe someone else is already running it. Okay? Okay. Okay, here comes, okay. Okay, okay, some exciting things are happening in Sector 1. I'm preparing to investigate. Okay, yeah?
Age in years, I think I've got errors. So age in years, I need to rename.
It should be age in years.
Okay,
Yeah.
and then the other thing, that home cannot be resolved. So I need to somehow.
Okay, okay, yeah, so maybe we double click on this guy. The homes cannot be resolved. And it will take you to where it is.
Oh.
It's homes .random. Yep. Yeah, just like she said. Okay, looks like it's happy.
All right, let's try it. Yeah, they're taking pictures of the screen and voting.
That's great. Yeah. Okay. Oh, that's exciting.
Right, but right now
That's interesting. Okay. So,
start out now?
well, yeah, but they're wow, that's really neat. Okay. Oh, wait, but are they moving?
No.
Okay, so can I see your trend state charts? Okay, let's go see this. Okay, first of all, let's make, well, okay. So that looks pretty good. So this, yep, I don't see a problem with that. That looks great. Okay, here's leaving home after 16. Yeah, age and years that. Okay, that's good. Yeah.
What age should I make my people?
Well, yeah, that's what I'm wondering if that's specified here.
Because they might not be old enough to
Precisely, that's what I suspect. Okay, so let's go to here, and then let's go. Hey,
I don't think I did it.
and then let's go to this. Oh yeah, you need to make it uniformly distributed between 0 and 65. Yeah. Okay. So characterize the behavior exhibited by this model. Okay. Yeah. So there exists a diurnal, a pronounced diurnal pattern, whereby people move between homes, workplaces, and schools. So here people are at home, families are together. You notice there's often more than one person at home. And then at the crack of dawn, people move from homes to the workplaces or to the schools. Here they're back home. But some people remain in those homes. Who are those people remaining in the homes? Yeah, those are children. Those are kids who are not yet of school age, right? Here's a home co-located with a factory. But let's hope it makes children's toys or something. Yeah. Oh, okay. Interesting. So they're hidden behind it. So, sorry. I suspect it may be, but there's probably a way to change it. Did you try this bring to front? You did. That's in. Sorry. I'm in the person tab, and I was thinking that it was set by the order bring to front. Oh yeah. Yeah. Correct. Yeah, they'll appear offset from it. So their appearance, they're at some logical location, but that will direct their appearance to be at a slightly offset visual location. Okay. So another thing we could do here, any other questions here right now? Suppose we wanted to now have each of the locations have a size indicated by visually, which indicates the number of people in it. How do we do that? Okay, let's do school. Okay. There's going to be scale and X and Y. That's right, but we're going to need to somehow say how many people are there right now, right? And there's a couple of ways we could do that. We could ask how many agents are near us or within such and such a range. Give me a minute. I might try a different strategy. I had in mind a certain strategy, but let me just see. Yes, I could say agents in range and ask for a range of 0. And let me just try this. I'm going to just try this for the scale. We'll see if this actually is viable. So we'll see how many agents are right atop of us. Oh, it's an unhappy camper. Operator, okay, yes, agents in range, of course. I wanted to do agents in range 0 dot, and we ask how many of them. So I could try this, but there's another way that's a little bit more cumbersome, but more reliable. So I'm gonna just try this now. Okay, hey, look at that. But okay, yeah, but that isn't okay, that's the scale. Oh, this is the scale. It's not the size, it's the scale. So we actually want it to be 1 plus that, not so okay, let me just go to the whole thing. So we want it to be 1 plus it, because the scale of 1 would be a normal scale. But still, it didn't seem to exhibit any change when people came to it. Okay. Yeah, exactly. So I suspect it's not effective as a technique, but I'll play around with it. I think this is a new function in AnyLogic 7, and so I want you to try this out. If I said within 10 sort of spatial units, that also might capture, but I would have expected 0 spatial units because they're really right on top of it. But I don't think it's a viable technique. Yeah. Scale will be the size is sort of how wide is it, for example, for like a radius of a circle, or you could set a size associated with like maybe a square or something like that. But scale is how many times it's blown up. So if it's 2, it's twice as big at normal range. This is not specified. Size is not specified for this whole school. That's the thing. Okay, so folks, we're going to have to do it a different way. I was hoping that this nice little thing here would capture it, but it doesn't. So what I'd like to do is what are we going to have to maintain for a school? We're going to have to maintain a count of people who are in it. Okay? Okay, so what do we have to add to that? Would it be a variable? Is it something we tell the school when it's created, how many people are in you? Or is it is it a parameter which we tell when it's created, or is it a variable? It's actually a variable. It's a sort of, because it'll be changing over time, and it's not something set purely initially. So this will be count of occupants into the school, and it's going to be, if it's going to be a count, what sort of type is it going to be? An integer, and its initial value will be 0. Okay? No, because it's within school. We don't have to worry that it will clash with any others, because we'll have to say like school dot count of occupants, so it will be clear from context. Great question. Okay? And fortunately, we don't have to worry about occupants within a person, but within a home, we're going to have a similar account of occupants, right? Yeah, let's copy and paste it. Count of occupants for the home, and then a count of occupants for the workplace. Yeah, copy the variable and paste it. So we have similar variables. Now, there's a more elegant way to do this, and I have another model which is given to you as an example model where I have a sort of general institution class, and that sort of groups, it characterizes these features, and any of them, you know, a school is just a type of institution, a factory is just a type of institution. That affords us an economy of description. But here we want to set the number of people that are there. Okay, that's great. And now, ladies and gentlemen, how are we going to maintain these things? This is another little lesson that I'm hoping to give you. How do we maintain them? We have to think carefully about this. We have to think very carefully. So when do we have to change the count of occupants of a thing? When does it have to be? We're going to have to maintain it. We're going to have to do some bookkeeping.
Entry and exit.
Entry and exit. So great. So what would happen? Let's take the home as an example. When we enter a home, what do we need to do with the associated home? We have to increment home dot count of occupants. Remember, autocomplete is your friend.
And home capital H?
Yeah. No, lowercase h, because it's the variable, right? And how about when we leave the home? What do we have to do? There's a minus minus. And it makes it one smaller. Okay? By the way, you notice this is something that's much better done in the entry and exit actions. We don't want to do it separately for each of the transitions out. It'll be a nightmare. Every transition we have to remember to add it. A mess. Let's do it on the entry action, the exit action.
Where do we initialize it?
Okay. We set it to be an initial value of 0.
Where do we do that?
We set it when we declared the variable. So we'll go back to that. I'll revisit that, okay? So let's keep our momentum here. So what do we have to do with school? In the entry action, what do we have to do with school? Okay? In the entry action, we need to increment that. Okay? School dot count of occupants, right? Plus plus, and then when they leave the school, what do we do? Minus minus. Okay? Okay. How about the workplace? How about the workplace? Workplace dot count of occupants plus plus. And how about the exit action? Minus minus. Okay? Okay. So that's pretty good. But we also have to make sure that they start initialized, so they have some initial value. So let's just go verify that's been done. So where would the initial value for that variable be could it be set? Well, one place is we could set it up here, but that could be awkward because many people share the same workplace. So let's go to home, and we can see when we declared the variable, we made its initial value 0. Okay? Okay, make it 0. Yeah, I set that, but it may not have been clear. Okay, then person.
And does it default to anything if you leave it blank? Does it default to 0?
It's uninitialized, which is different. Which basically is a good thing because it will flag the problem that you haven't caught it. Count of applicants for school should also be 0 initially. For school, the count of occupants should be 0 initially. And similarly, for workplace, make sure they're all 0 initial value. Does that make sense? Okay.
What if we don't initialize?
Then it will know it's a non-initialized value, and it will, you'll be able to see it visually. If you try to use it, it can cause an error. Yeah. Okay? Okay, folks. So that's great. Do you want to, so we have two options here. Why don't we go run this and we could visually inspect and see if those counts are being maintained. So go to run. And here we have people in their homes. Why don't we pause the model and let's go down and look at the homes. Here we go, look at homes. This home has 4 occupants. This home has 6. This home has 8. This home has 5. This home has 2. This home has 2, 7, 8, 1 occupant. Do you see that? Do you see that? Okay, let's run this forward a little bit. Those occupants should sometimes go, like if it goes forward to time 16, that number of occupants in the home could potentially go down. Now it's gone to 0. There's very few people after time 16 in the home. Why is that? After time 16, where are they? Most people, they're at work except for the babies. Okay, moving right along. Okay, so what do we have to do to have it visually appear? Okay, how do we have this be visually appearing? Okay, how if we want to actually have the home appear bigger? What did I hear? With a scale. Okay, so let's go to home and make it scale depend on the number of applicants, the number of occupants. Okay, so where do we set it scale? Yeah, click on the picture, scale down. Okay, and let's set it by count of occupants, right? Let's make it 0.5 plus this or something, so it'll still be visible without any occupants. But then the more occupants it has, the more it will, the bigger it will be. Yeah. The scale, it's just double its size. 2 would be double its normal size. 10 would be 10 times its normal size. So I see a problem with scalability. Because like the workplaces maybe have very many people, or the schools, and those are going to be really big, right? So we might want to put in a factor here, 0.5 plus 0.1? Okay, yeah. We're working on home. Maybe not. I was thinking of scaling consistently, but sure, we could leave them like this. Let's test out the strategy with homes. Let's try it out, see how well it works. Try it on for size, and then if it works okay, we'll scale up and roll out. Okay. Okay. So let's run this thing. Oh my gosh. Okay. Okay, the night is passing. Okay, here comes morning, and now we're down to. Okay, yeah. So there's a lot of homes here. 0.2 times it. Okay, good. Okay, so we're having these people go back and forth. The homes are crowded. Okay. Okay. Great. So we'll go back and we'll take the advice from people who've been researching it. 0.2 times this. Yeah. 0.2 times this. 0.2 times this. Yeah. Okay. 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 Shall we roll up and scale out? No, scale up and roll out. Okay. Okay. So let's set for the workplaces. Do we want to use the same scaling or a more modest scaling? Yeah. Maybe we'll do 0.5 plus 0.1 times the count of occupants.
Yeah, I did 0.2 for the home, 0.1 for the workplace, and 0.05 for the schools, and what's we welcome.
Okay. And then for school, Kristen, you used what?
I did 0.2 for the home, 0.1 for the workplace,
Yep.
and 0.05, I think.
For the schools?
I think so.
Okay, Kristen did 0.05 for the schools, so I'm going to do this. Now note that there's a better way to do this. I would define a function that says scale, and I would just call the function instead of repeating this. This is bad practice to go repeat this multiple times. I would call a function like, get scale, and it would just return this. I'll just show you how it could be done here. You don't have to follow along, but functions are your friend. This would be called get scale, and then I just have to change it one place. If I want to refine it later, I would just change it a single place, namely at this place. So here I defined a function. I tell it returns a value, a double, and this is what it returns. And then I would call up in this, I would just call wherever it's used, instead of repeating this. I mean, that's quite horrendous to see that repeated so many times. I would just call get scale, get scale, get scale. Okay? So can we try this? Okay? Sorry? Well, it's a good question. If it were going to be reused, but I think in this case there's an argument to be had for you know what? There's already a thing called get scale. Gosh. So I need to make it called get visual scale is the function. Would I put it in main? No, because each type has a different function, has a different formula. Yeah, you could put it in main, but the other place I would create a what's called a super class, a super type. It would sort of be an institution, and it would know how to compute scale, and it would basically all of them would be institutions. They would just differ in their icons, and so you just define it one place for a whole bunch of different types of institutions. But it's a similar idea. You define it one place. Okay, yes?
Could you use the table function and have it look up like school class and then have the scale change on it?
Yep, that's a neat idea. So you could look up for this many people, how big should it be, right? Yep, I think that's a nice idea. Absolutely. Okay, folks, so here we go. We see this pattern. So here's home, here's during the day, here's at home. You could see the homes with more people were distinguished in size, and you could see workplaces that are more concentrated, distinguished in size. People move between these things. Now, obviously, the mobility here is not really buying us anything. But if we wanted to record people's exposure to bad air quality in LA on the way to work, or we wanted to capture exposure to influences on a person's attitudes and beliefs through advertising or promotion by fast food restaurants or by associated with tobacco advertisements, capturing their movements through space might be useful. And this affords us a way to do that. So any questions about this? Any questions? Okay. So that's good. With your leave, I'm going to show you then another model, which I put up on the Google Drive share, but I suspect you folks don't have it in your computers because I put it up since the beginning of the boot camp.